Okay, question number 5. So p squared minus q squared plus 2pqi equals 119 plus 120i. So we take the real parts, p squared minus q squared, and we set it equal to the real number 119. We take the complex part, 2pq, and set it equal to the complex coefficient 120. So the way that we want to solve this, the 2pq, we can solve for p or q. And the idea is if we can get p or q alone, we substitute it into the other equation, because what we're really doing is a system of equations here. And that. So we substitute it in the second equation and we solve for the variable. So 2pq equals 120. Divide both sides by 2p, and we get that q is actually equal to 60 over p. And that's what we're going to do. We want to write an equation in terms of one variable. You can never solve an equation with more than one variable. So here, by getting it down to the variable p, we can solve this equation. It takes a little work, but we can do it. So here, p squared minus 60 over p squared equals 119. We're substituting. So don't forget that this needs a square and that. So the problem is we have to square what's in parentheses. So we square the 60, we get 3,600. When we square the p, we get p squared. Once we're at this point, what we really need to consider is we want this p squared out of the denominator. So we're going to distribute p squared all the way through the entire equation. So p squared times p squared gives us p to the fourth. P squared times our fraction makes the denominator go away, so we're left with negative 3,600 equals 119 p squared. So now I want to write this as a trinomial that I can factor. So I just subtract 119 p squared from both sides. And now I've got p to the fourth minus 119 p squared minus 3,600 equals 0. And this is where we're going to factor. Now, because this sign is negative and this sign is negative, I know that my signs are different. So I know I'm going to have a plus, I'm going to have a minus. I know that p to the fourth breaks down to p squared and p squared. So the real trick was just factoring the 3,600 and finding something that summed up to the negative 119. Now, this didn't come to me automatically. Luckily, we've done this problem in another way. We already did it using the polar form. So I kind of knew that the 5 and the 12 were involved there. So the 144 and the 25 were sitting there kind of obvious. And 144 times 25 is 3,600, right? And negative 144 plus 25 is the negative 119. So that's where those values came from. But now we can do what we did yesterday. We can break down p squared plus 25. We can break down p squared minus 144. So remember, when it's positive, difference of perfect squares, we have to include the I. So we've got p plus 5i, p minus 5i. When we just do difference of perfect squares, we've got p plus 12, p minus 12 equals 0. So these are the 4 possible values for p. But the main thing you need to remember is when we're talking about a complex number, p plus qi, the p is the real part. That means that the real part has to be either the 12 or the negative 12, because when we solve it, it's inside opposite. So these are the true values for P. The negative 5i and the 5i do not work for P because P is the real component. Q is the complex component. But once we have these for our reals, that means that these are the complex. So we've got all our factors right here. Now, since 2PQ equals 120, 120 is positive. That means that P and Q both have to be the same sign. So, if P is negative 12, it's going to go with minus 5i because both signs are negative. If P is positive 12, then it's going to go with positive 5i because both signs are positive. And the product of 2PQ is a positive number. And that's how we break this down algebraically.